In example 4, we're finding the inverse of a quadratic function when the restriction is not specified. We restrict the domain and then find the inverse of the function x minus 2 squared minus 3, as you can see graphed to the right. We can see that this is a parabola with a vertex at 2, negative 3 that opens upward. Because the graph will be decreasing on one side of the vertex and increasing on the other side, we can restrict this function to a domain on which it will be a one-to-one function by limiting the domain to where x is greater than or equal to 2. So that means we're only going to look at half of this graph so that it becomes a one-to-one function, and this is where x is greater than or equal to 2. So to find the inverse, we will use the vertex from the quadratic. And then we start by replacing f of x with a simple variable y and then solve for x. So the first step is to replace that f of x with y. And then we're going to interchange x and y in step 2. And then we're going to add 3 to both sides, which is what we do in step 3. And then in step 4, we need to take the square root of both sides. So when we take the square root of both sides, you will see that we get plus or minus the square root of x plus 3. And then we need to add 2 to both sides. So we're going to end up getting f inverse of x, which is equal to 2 plus or minus the square root of x plus 3. So now what we need to do is we need to determine which case to use. So because we restricted our original function to the domain of x is greater than or equal to 2, the outputs of the inverse should be the same, telling us to utilize the positive case. So therefore, f inverse of x is going to be 2 plus the square root of x plus 3. Now, if the quadratic had not been given in vertex form, rewriting it into vertex form would be the first step. This way, we may easily observe the coordinates of the vertex to help us restrict the domain. Now let's take a look at the analysis. Notice that we arbitrarily decided to restrict the domain on x is greater than or equal to 2. We could just have easily opted to restrict the domain on x is less than or equal to 2, in which case f inverse of x would have been 2 minus the square root of x plus 3. Observe the original function graphed on the same set of axes as its inverse function in figure 7. Notice that both graphs show symmetry about the line y equals x. The coordinate pair 2, negative 3 is on the graph of f, and the coordinate pair negative 3, 2 is on the graph of the inverse. Observe from the graph of both functions on the same set of axes that the domain of f is equal to the range of the inverse, which is bracket 2 comma infinity, and the domain of the inverse function and range of f is equal to bracket negative 3 comma infinity. Finally, observe the graph of f intersects the graph of the f inverse along the line y equals x.